Okay, so this is today, here, today. Sorry I'm out today, guys. I am working with some of our fellow math teachers on some curriculum stuff for you guys. So we have a sub today. Here is today, the 27th for you guys, my even classes. You have a unit test, December 3rd. That's a Monday. I know I put it there on Saturday, December the 1st. I just didn't have enough. I didn't have the next week for the 3rd, so keep that in mind. You have 2 more class periods before your unit test. Okay. All right. So we are working on today. We're gonna do 4.3 and 4.2. Okay, 4.2, 4.3. And we are working on, again, we're looking for side lengths of similar figures if they are unknown. Okay. So if you talk to your classmates that have my classes on odd days, they said that we went outside. We'll do that next class. We just couldn't do it today because I'm not there today. So today is 11/27 for you guys, 2018. And it says we are going to be working with ratios with similar triangles and using similarity to find side lengths. We've done these items before. We're just going to do them again in slightly different ways and just getting a little bit more practice with them. Okay. So it says given two shapes, our essential question, how can you use, it's a big blank, our blank is ratios of corresponding sides to determine if they are similar. So we're going to check if they are similar, and we're going to use that similarity to identify unknown side lengths. Unknown side lengths. Okay. So there are 2 ways to do this, method 1 and method 2. Or sorry, one method and another method that's indicated on your notes. And the first one we've done a lot of times. This first one is using scale factors. So we've done this one plenty of times already. You should be getting very, very good at it. Okay. The one that uses ratios, over here, this one's a little bit different. We covered this last class already once, but we didn't cover it in depth. So we'll go over them again. Okay, so what I'm going to first do is I'm going to identify side lengths on similar sides because it's telling me that these figures are similar. So because what I'm highlighting or outlining them in the same color, these sides correspond to each other. They are the same side lengths in the same shape. Okay, so I started with the shortest side in blue, the longest side in each of the 2 triangles in green, and the medium side in red. So the question to the right where it says another method is the exact same question. We're just going to solve it a different way. Now you can solve these in any way you'd like to, realistically, but what I recommend is that you at least know the first way, and we spent a lot of time covering the first method, the method on the left, which I'll go over first, because in the first one it gives us an idea of what scale factor is. Okay, so I'm going to start off with scale factor, and if I'm looking for my x value here, so if I'm trying to figure out my x value, this one becomes my image. Wherever my variable is my image, and this is my pre-image. Now, before you write this down, those will switch when I'm looking for the y. So I'm going to erase this for now, and I'm going to write this off to the side. Okay. So a little bit of some notes here. So very not pretty star. Whichever shape has the variable, which is your unknown, whichever shape has the variable or your unknown is the image. Okay, that can change, so keep that in mind. That can change. I'm going to add another note here in a slightly different color. Let's do red. And I'm going to say that you should always start with corresponding, that's a C, corresponding sides of known values. Okay, so I'm always going to start with sides that I marked in the same color that I know both of the numbers to. So always start with corresponding sides of known values. Okay, in this case, in our first question, actually in both questions, because it's the same question, I'm going to start with 12 and 4. I'm starting 12 and 4 because I know both of those numbers. This blue number and this blue number, I know both of them. If I look at my green numbers, I only know one of them. If I look at my red numbers, I again only know one of them. So I want to start with my blue numbers first. Okay. So with my blue numbers, I'm going to always go towards my image. Okay. Towards your image. 12 to 4. Because that should match my 18 to x. Okay. Looking at which way the arrow is going, my arrow always points to my unknown value. So here's my first equation. My first equation is 12 times something, 12 times something equals 4. And that's a little bit strange for some of us. If I multiply, I'm used to them getting larger. But again, our scale factor can be anything. If it's less than 1, it makes it smaller. Okay. Now this number here, as I just mentioned, is your scale factor. Okay, this is scale factor. Okay, this number is scale factor. Okay, and using scale factor, okay, is a combination of these two numbers. It's a combination of that last number and the first number. That's 4 over 12. I can always find my scale factor if I know the lengths of corresponding sides. If I know both of them. So I know both 12 and 4, they make up my scale factor. Now because it's pointing towards the smaller number, or sorry, it's pointing towards a smaller shape, that means my scale factor should be less than 1. And 4 over 12 is 1 over 3 if I reduce it. You don't want to reduce it, you don't have to, okay? But you will lose points if you don't reduce it completely, if reducible, okay? But when you're using it, you can use it just as it is, okay? Now, I figured out the blue one, which wasn't really a mystery. We already knew what it was. So we're going to do the same thing with the red numbers. This time, on the big one, we started with 18. That's this number over here. And we're going to multiply by some number. Multiply by some number. And then after that, we should end up with our other unknown value, which in this case is our x. Okay. Now, that unknown number that we're multiplying by, it's the same number. It's the same one over there. Okay. So I don't have to guess. I did this first question so I could fill this one in. Okay. So this number here will be the same number, 4 over 12. Now, multiplying by fractions is not as difficult as it looks. Okay. And I'll show you how to multiply these two numbers together. So if you were to write this in a straight line, it would look like this. 18, first number, times, that's right there. 4, that's this number over here. And then divided by, that's that little bar right there, divided by 12. This number right there. And all that should equal our value of x. Good. Now, I type this into my calculator, not as difficult as it looks. You could type it into, you could do it longhand, it just takes a little bit longer, but not too difficult. 18 times 4 divided by 12, and we end up with 6. So in this case, x equals 6. That's our answer. So we now know that the value of x is 6. Now we do this all over again one more time to figure out what y is. Now, when we figure out y, there's a slight difference, okay? Instead of going towards 4, I'm going to go the other way towards 12 because my green numbers go towards y. So if I'm going to go towards that unknown, both of them should go towards that direction. So I'm going to do the same thing all over again, but this time I'm going to use the darker blue to indicate my 4 to 12, my number getting larger. So this time I'm going to use the same two numbers as 4 and 12, but I'm going to go the other way. 4 times some number equals 12. Okay. Now this number here, okay, is a combination of these other two numbers, and we've already done this before, but this time there's a slight difference. Our slight difference is the 12 goes on top and the 4 goes on the bottom. 4 times something will give us 12. That's obviously a 3. But again, if you don't know what that number is, you combine those two numbers together and you get 12 over 4. And this is our scale factor. This is our scale factor. All over again. Scale factor. But this time our scale factor is larger than 1. It's 12 divided by 4, which is 3. And we can use that again for our green numbers because our green numbers are getting larger. It goes from 8 to something over here, which is a longer value. So I'll use that same scale factor. 8 times 12 over 4. 12 over 4. 12 over 4. That's my mystery number that we figured out. And that's going to equal the value of our y. Now you could just do 8 times 3, which is fine. Or your other option is to write it out in longhand. If you want to make sure, 8 times 12 divided by 4 equals the value of y. Scoot that up a little bit. There you go, that's better. Okay, and again, into my handy calculator it goes. We have 8 times 12 divided by 4, and we get 24, which is what we were expecting. Y equals 20. Okay, again, pause if you need to, rewind if you didn't get it. Okay, now that's method number 1, finding a scale factor. Each time we found this number in the middle, the amount of change that happened from one to the other. Now, on the right side, we're going to use the other method that we learned last class and we didn't get to spend very much time on. Okay, this method off to the right, what we're going to do is we're going to set up ratios, and we're not going to have lines going across here. The lines are crossing my two shapes. On the second time, I'm going to set up ratios of adjacent side lengths. Lots of big fancy words, but it's not as difficult as it sounds. What I'm going to do is I'm going to connect these two numbers. You see how this time when I'm comparing my numbers, they're on the same triangle. And I'm going to compare it to these two numbers here. I'm going to find a blue-green connection, and I'm going to make it, I'm going to compare it to the other blue-green connection. Okay, so these are equivalent ratios. They are proportional to each other. That word proportional are two ratios set equal to each other. Now what I'm going to do is I'm going to set up my equation as green over blue. I could have blue over green if you want, but in this case I'm just going to put green over blue. I do know this first one, which is 8 over 4. 8 over 4, wrong color. 8 over 4, that's this first one over here. And that needs to be equal to, I'm going to give me some space over here. That needs to be equal to my other green number, which is y over 12. Okay. So what I'm going to do is I'm going to multiply, or I'm going to double or triple or divide, whatever I can do. I'm going to change it. I'm going to change that first one, this first one over here. I'm going to change this one until it matches something there. I don't know what the y is going to be, but I do know what the blue one is going to be. So what I'm going to do is I'm going to double this one, and then I'm going to triple it, and I'm going to quadruple it until I get what I'm looking for. So the next one I'm going to do is I'm going to do this whole number, and I'm going to multiply it by 2 over 2. Okay, and I'm going to make the same ratio just bigger. So I'm going to make a comparison of two numbers. This one's going to be 16 over 8, 4 times 2, which is going to give me 8. Now, this number here, all three of these ratios, this one, and this one, are all equal. But what I don't know is what this y is on top yet, because my numbers on the bottom, my blue numbers, aren't to 12 yet. So what I'm going to do is I'm going to do it all over again. But this time, instead of multiplying it just by 2 over 2, okay, see this 2 over 2 here? That's the value of 1, okay? I'm going to do that again, but this time, what I'm going to do is, I'm just going to get rid of this. This time I'm going to multiply it by 3 over 3. So, times 3 over 3. Well, 8 times 3 is 16. 8 times 3 is 24. And 4 times 3 is 12. Okay, so I did the same thing, but this time I multiplied it by 3 instead. And what you'll notice is now I have two numbers that are equal to each other. These two. In fact, all these ratios, they're all equal to each other. Each one of them is equal to the other one, but I needed to make sure that they ended up being the same. Once the blue ones matched, the ones that I did know, I now know that the green ones match as well. Okay? Good. So I used the ratio from the small one, the 8 over 4. This is the small one. Okay? And I slowly enlarged it until it matched the big one. Okay? Now there are other ways to do this, which is completely fine. I'll show you another way. One is you can find the ratios until they are equal to each other by slowly enlarging them. The other option, okay, is if we get rid of this. Okay? Now we got to find the x value. This time, let's set it up this way. These two, blue, red, and blue, red. Okay. Well, again, let's set that up. Let's put the, I don't know. I kind of like my numbers that are a little bit larger on top. That just makes more sense to me. So I'm going to put the 18 on top in red. I have the 18 over 12. Oh, maybe I should put this on the other side. 18 over 12. Okay, because I know both of those. And I have to somehow figure out how it's going to match 4 under x. So again, I have my colors matching. Okay. Red's on top, blue's on the bottom. They are equivalent ratios. The blue-red on the big, the blue-red on the small one. And I have to match them up. Okay. So they are equivalent ratios. They are proportional right now. Okay. And I can't make this bigger for the 4 to match. So what I have to do is I have to make the big one a little bit smaller so it'll match. Okay. I could do 18 and 12. I have to divide them by the same number. So I'm going to divide both of these, divide them by 2 over 2. And I end up with 9 over 6. Not quite what I wanted there, which is fine. Let's do something else. Are they both divisible by 3? That looks so good. Divide by 3, divide by 3. I end up with 6 over 4. That's good. That's good because these two match. The 4s match, and that means that the tops should match also because I'm just adjusting by 1. Okay, that 3 over 3, this is changing by 1 or multiplying by 1, which doesn't change anything at all. Okay, so in the end, I ended up with x equals 6, x equals 6, y equals 24, y equals 24. Either method yielded the same answer, just depends on how you want to go about finding that answer. Okay, again, pause it as necessary, copy this down. If you need to, I'll post this online so you can watch it again and again and again because you love math so much. So go ahead and pause the video. You're going to try and do A on your own. Okay, if you just play the video and watch me do it, then I'm taking away all the fun. So have some fun on your own. Do question A by yourself. Okay, And then if you're not sure, hit the play button, copy it down. Again, I'll do this 2 different ways so you can see them in both in action. Okay. All right, so the video is paused for like 10 minutes, I'm assuming, and now you're checking to see if you got the work just right. So what I'm doing is I'm finding corresponding sides by marking them with the same color. Short side in blue, doesn't really matter which colors you choose. Long side in red, okay, and then my medium side in green. There we go. That means the one I'm looking for is green, and I know the red ones and I know the blue ones. So I only have to find one item. I know I'm going to be going towards the big number, so my scale factor is going to be enlarging. It's going to be greater than 1. And I have an option. Do I want to do 1.5 and 3, the blue numbers? Or do I want to do 6 and 12? Well, you know what, to be honest with you, I know 6 and 12 are bigger numbers, but at least I don't have to deal with decimals. So I'm going to go with 6 and 12. So from 6 to 12, I have to do the same thing. I have to figure out the amount of change from one to the other. And because I'm always starting with corresponding values, known values, okay, I'm going to start with my red numbers. In this case, 6 times something becomes my other red number, 12. Those somethings, that unknown value, is a combination of these two, which is 12 over 6. So I'm multiplying by 12 over 6 to go from the small one to the big one. Now, when you think of 6 times something, you're like, well, n equals 12. You automatically kind of know that it should be 6 times 2. In this case, 12 over 6 is 2 because 12 divided by 6 is 2. This is our scale factor, and we will use it again. We're going to use this again to figure out the number on the bottom. Okay, so now I'm going to do the same thing with my green numbers. I start my arrow off at 5. I multiply it by something, okay, and that something is this same set of numbers, 12 over 6, or multiplied by 2. Okay, multiplied by 2, and we end up with, well, green numbers is our unknown value. Okay, now our unknown value is going to be 5 times 12. I'll write this longhand so you can see the whole thing. 5 times 12, 5 times 12, divide by 6, and that should be our question mark. That ends up being 5 times 12, which is 60. That's 60. Divided by 6 is 10 equals x. 10 equals x, or x equals 10. Okay, so I got x equals 10. Now, again, you don't have to do it that way. You can use adjacent sides. So if you like that way, you can stop paying attention and go and move on to the work on your own. Okay, the numbers on this side, I'm going to use the other method. I'll set up adjacent ratios. Okay, so I'm going to set up these two and these two. Again, I want to stick to my whole numbers. I'm going to use red over green. I don't know why. I could choose whichever one I want to. Again, I like my big numbers on top for some reason. I'm not sure. 6 over 5. Okay, that's my small one. That's this one over here. Okay, so 6 over 5. And I'm going to compare it to the one on the left, which is in green, it's going to be x, and on top is going to be red in 12. Okay, now I'm going to slowly increase this until they match up. So I'm going to multiply it by 2, multiply by 2 over 2, I'm sorry, multiply by 1, because that's a 1. Okay, so 6 times 2, that's 12. And 5 times 2, that's 10. And now I do have equivalent ratios. Now, these two are proportional, or they're completely equal. Okay, so these two are completely equal. We now know that x equals 10. okay? And this, they're the same. We just went about them different ways. Okay, same answer. All right, I'm not gonna do B and C on here. Okay, you can work on those on your own. Okay, either method is okay, the choice is yours. Ratios on the right, you can use scale factor, the method on the left. I recommend scale factor, gives you a little bit more information. Adjacent ratios is great because sometimes that's a quick and easy way to do it. Sometimes it isn't, but either one will work. So again, B and C you will complete on your own. Okay. You're going to work on D as much as you can. I'm going to go over this in class again next class, but I'm going to go through the work here now so you can see it. Okay. All right. So pause the video, get about 10, maybe 12 minutes to work on B and C, and then hit play again. We'll work on D. Okay, so you were working a little bit already on C and D. I'm assuming the video paused. So we need to find a few things here. We need to find the value of X, which is here. We need to find the value of Y, which is here. So I kind of got to go from the big one to the small one, and I got to go from the small one to the big one. Okay. We also need to find the perimeter. Okay, that's the distance around. How long is this plus this plus this one and this one and this one and this one and this one. Okay, and for the big one and the small one, because it asks for it twice, let's find the area and perimeter of the other figure. So we kind of need to also find, even though they only ask for X and Y, we also need to find this length here, which should match this length here. We got to figure that part out. And we need to figure out this length here, this one, and this one. Right now, they don't have any values, so we got to figure those out. Let's figure out this X and Y first, because those are our first two questions. Maybe there's a reason why they put the questions in this order. Okay. Now, let's do X in blue. I got to figure out that one, and it matches the side. They're corresponding sides. I have to go towards my X. Okay. So that's 1.75 times something equals my, in this case, our X value. Now I have to figure out what that something is. So I need to use known values. Okay, I'm going to use 14 and 8. Sure, I could use 5.25 and 3, but who wants to use 5.25 when I can use just whole numbers, which are 8 and 14. So I'm going to go in the same direction. I'm going to point towards the same figure, towards the one with the variable X, because that's what we're solving for. I have to go from 14 times something equals 8. Now this number here, this number I'm going to put in the middle is the same. This number will be this number. They are the same number. So the number that I'm using is going to be a combination of 8 over 14. And I'm going to use the same number in this bottom box down here. I'm going to call it 4 over 7. Okay, now that might have... Okay, so 4 over 7 is the same as 8 over 14. And again, those are the same set of numbers, just one is reduced compared to the other. So into my calculator this goes 1.75 times 4 divided by 7, and all that will equal the X value that we're looking for. Okay, now 1.75 times 4 divided by 7, and we get 1. All that work, and our goal was to get the value of 1 here. Okay, X equals 1 or 1 equals X. Either one is okay. Okay, now we'll do the same thing all over again, but this time we're going to do it in the other direction. Okay, I'm still going to use these whole numbers here, 8 and 14, but this time I'm going to point towards the 14 because I'm going to use and compare it to this 4 into the Y. Okay, so I'm going to use the same thing, but this time I'm going to compare the 4 and Y. I'm changing directions. I'm going to do the work inside this shape here just because I don't have very much working space without zooming out too far. So 8 times something, 8 times something equals 14, and that something now is 14 over 8. It was 8 over 14 before, now it's switched because I'm going the other direction. Because I went from big to small, it was less than 1, now I'm going from small to big. It is larger than 1. Flips over a reciprocal, okay, to find the other direction. Okay. Now I have my scale factor right here. This is my scale factor from small to big. I'm going to reproduce that same value, but this time I'm going to use my red numbers. Okay, 4 into y. But this time I'm going to use multiply by 14 over 8. I'm going to use the same set of numbers, okay, my same scale factor as before, but this time just using red. Okay, into the calculator this goes 4 times 14 divided by 8, and all that should equal the value of y, which we're looking for. Okay, so we've got 4 times 14 divided by 8, and we're left with 7. Okay, go away calculator. Okay, so we're left with 7. Y equals 7. Okay, now I know that the value of this side length over here is 7. Okay, now we got to use this information to figure out our other two missing side lengths here. Okay, so what I'm going to do is I'm going to draw a box because they look kind of squarish, and I think that will help us. Okay, so from here I'm going to make this into a regular box. Now, if that was a rectangle, and I know that the length from here to here is 8 units, the distance from here to here should also be 8 units. Okay, now if that's 8 units, I've already used up 5 from here to here, so this section got used. 8 minus 5, I'm left with 3 altogether. Now, there are 2 more horizontal sections. There's this one here and this one here. Okay, and I know one of them is the blue one, which is 1. So if I have 8 minus 5 is 3, I have 3 left to use. I used up 1 for the blue one over there. That means my unknown section is a value of 2. Okay, I have a full length of 8. I used up 5 and a 1. Whatever I have left is that last horizontal section, 2. Okay, now I'll do the same thing here for this big one. Okay, I'll make I won't say nice straight line, but that wasn't very nice. It's kind of crooked. So here is my box. This is 14 over there. So far I have 14, and we used up 8.75. Okay, so 14 minus 8 is going to leave us with 6, and then we minus 7.5, which leaves us with 5.25. Okay, now 5.25. So we have 5.25 left over after subtracting this section from here to here. We've used up that much, 8.75. We also have a 1.75 section that we can account for too, so minus 1.75. That takes us to 4.25, because 5 minus 1 is 4, and then I'm going to minus that 0.25 from 7.25, so 5.25 minus 1.75 should be 3.5, quarter, yeah. So we're left with 3.25 here. 3.25. Okay, that's this mystery section here. 3.25 from there to there. Okay, all right, now I've got all my values for all my side lengths all the way around. Okay, so all the way around, everything is accounted for. There we go. Good. Okay, so we got the x, we got the y. Now we just have to get the perimeter of one and the other. Okay, So I'm going to add them all up. So for the small one is, I'm just going to list it small. The small is 8. Oh, wait, we got to get one more side. We're missing one. All right, so let's go back to here, and we'll put those squares back up. Okay, I took the squares down too early. So in a different color, or same color, whatever, I'm going to make my box. Okay, this side is 4 and 2, so this side length is 6. That means this side length is also 6. If the left side is 6 and the right side is 6, and I used up 3, 6 minus 3, that means this section is also going to be 3 units long here. Okay, so I have 6 units tall. This distance here is going to be 3. Okay, I'll do the same thing over here, but I'm not going to draw my big box. My side length from here to here is 7 and 3.5, which means that's going to be 10.5 units total. Okay, so 10.5 units tall. And we have 10.5 from here to there as well, and we've used up 5.25. So minus 5.25, we're left with another 5.25. They're equal, 5.25. Okay. All right, now we have all the values we need. Okay, the small one, I'm going to add up all the values of our small shape. So I have my 8 plus 4 plus 1 plus 2 plus 5 plus 3 plus 2 plus 3. Ooh, it's kind of a lot of going on there. So I'll add all those up together. I'm sure there's a nicer way I could write this, but I'm going to leave it like that for now. The big one, we can do much the same way. Here's our big value. Our big will be 14 plus 7 plus 1.75 plus 3.5. 14, 7, 1.75, 3.5 plus 8.75. And I'm going to just keep going, add 5.25 plus 3.25 plus 5.25. Good, I got them all. All right, so add those all up, type them into the calculator, or do them longhand. Either one is fine. Again, you are allowed to use calculators on your test, so keep that in mind. Make sure you have a calculator ready to go. I have 8 plus 4 plus 1 plus 2 plus 5 plus 3 plus 2 plus 3, and we get a total of 28 units all the way around. 28 units, this is our perimeter. Okay. And we'll do the same thing for the big one. The big one is 14 plus 7 plus 1.75 plus 3.5 plus 8.75 plus 5.25 plus 3.25 plus 5.25. And we get a total of 48.75. Hope I didn't make any mistakes there. 48.75 for the big. Good. All right, we'll deal with area a different day, just because I feel like this is going to take up most of your class time. Again, I'm going to list your homework down here so we know what we're doing for homework. So, list it here. All right, so this is your homework for today. Okay, your homework for today. Let's get this out of the way. Okay, homework. Complete 4.2 to 4.3 notes. That's questions B and C. Okay, so you're going to complete questions B and C. Again, I didn't answer those here for you guys. Question B and C. Let's go. Okay, here's question B and C. These two. So you're going to finish question B and question C if you haven't done so yet. Okay. And then your study guide. Now this one is not due until Monday, December 3rd. Okay, I'm giving you extra time in advance to work on your study guide. You know how I make my study guides. They're very, very, very similar to your unit test. So if you understand the study guide, you can complete the study guide with no help, and you can retest it and redo it, not by memorization, but because you know the work. You should be good on your test. Okay, so 4.2, 4.3 notes, questions B and C. Your study guide due Monday. And last but not least, start to gather your notes. Gather stretching and shrinking notes. Stretching and shrinking notes. Okay. Now, I'm going to put a link on the Google Classroom for stretching and shrinking the cover sheet. Your cover sheet looks like this. Okay. This is what your cover sheet looks like. Yours is going to be slightly in a different, the dates are a little bit different, but these dates are fine if you put them in there like that. This is already posted online. You just got to scroll down to find it. These 7 sets of notes are due next class. Next class on test day, December 3rd. So this is due December 3rd, unit test. Okay, and remember, do not attach homework. I've already checked your homework, so don't attach it because I don't want to check it again. It just gives me a lot of things to do, and I get really distracted with all the things I have to check already. So, this and these items. So, 4.2, 4.3. Complete your 4.2, 4.3 notes, questions B and C. And if you can, your summary, you get a little bit ahead. Summary is not difficult. We've done lots of summaries together. Some of you are just waiting for me to tell you what to write, and you're losing a lot of learning when you just wait for someone to tell you what to do. So work on that question on your own. Figure out what we did in this video on how to solve it. Okay? Again, everything will be posted in the Google Classroom. Your test is Monday, December 3rd. Your notes and your study guide are due on that day.